Hey guys, since I'm out today, I decided I would record a quick little review of the lesson that we learned yesterday so that you could be hopefully reminded of kind of what we talked about yesterday so that you're prepared for the practice that you're doing with that today. I didn't want you to just go into the practice cold, having not seen this since what we looked at yesterday for the first time. So if you will, write your name on your paper right here so that when you turn them back in, I'll have them and can look over just the review that you did to show that you did work through that with me in the video and that you went through this. So just as a reminder, yesterday we talked about exponential growth and decay and how those kinds of functions are used for situations that are increasing or decreasing by a percentage. So when you see that, say, somebody invests something and it increases at 3%, or somebody bought something and it's decreasing in value by a certain percent, we're going to use exponential growth and decay functions to write those. Now, they still write in the same format of y equals a times b to the x, just like the other exponential functions that we've done. But remember that in these exponential growth and decay functions, that a represents the starting amount, the initial value, or whatever you want to call it. So what the investment or what the thing started out being worth. And then you're going to use the percent in the problem to determine the b value. Now, you cannot put the percent directly into the problem. You're going to use the percent to decide what the b is. So a can plug right in. B, we're going to have to use the percent to figure out. So let's remember how that works. Oh, okay, well, I have that in there twice. So the a in the function is the starting amount. I guess I put that in there twice. Sorry, y'all. You're going to be able to see that in the problem. It's going to say this started out being worth this. Use the b to determine the, use the percent to determine the b. Do not put the b, or do not put the percent directly in the problem. And yes, I'm yelling that at you. It's in all caps for a reason. Do not put the percent directly into the equation. You will be wrong every single time. Remember that when it's exponential growth, we consider that everything starts at 100, because 100% is the whole thing. And if it's growing, then it's going to increase from there. If it's decaying, it's going to decrease from there. So when it's growth, when it's increasing, you're going to add 100 to the percent. When it's decay or decreasing, you're subtracting 100 from the percent. Now, that's going to result in a negative number. Don't worry about the fact that it's negative. We don't care about that. We care about what the new percent will be. So you should be at bigger than 100% when it grew and smaller than 100% when it decayed. Once you get that number, you're going to change that number to a decimal by dividing by 100. Or if you know how to move it 2 steps to the left, great, do that. Get it into decimal form. Don't put the percent directly in the problem. You will be wrong every time. Then you're going to put that new number in for B. And again, we looked at this yesterday, but I just wanted to make sure we could recap on it real quick so you'd have a handy sheet of notes to look at too. So if you had a situation where they told you that the initial value of something was 300 and it was growing at a rate of 6%, you can write an equation for that to show that it started at 300. And then we got to figure out what goes in for B using the percent. Now notice I'm not putting the percent directly in the parentheses because I told y'all already not to do that. We're going to take that, since it's growth, we're going to add 100 and get it at 106%. I'm going to convert that to a decimal, and then that's what goes in the parentheses. So 106% converted to a decimal is 1.06. There's my function that represents the situation. So I can do the same thing for B. For B, I can say, okay, it starts at 10,000. I'm going to use the percent to figure out the B value. This time it decreases by 8.4%. So I'm going to subtract 8.4% from it. That's going to put me at 91.6%. It'll look like negative 91.6 if you do 8.4 minus 100. Is that 91.6? Now I'm second guessing my math on that. Hold on. Yeah, 91.6. So it gets 91.6%. Converted into a decimal, again, meaning I divide it by 100 when I get done, I get 0.916. So remember with these kinds of problems that this number should be smaller than 1 if it's a decreasing, a decay situation, and that number should be bigger than 1 when it's a growth situation. So what if they gave me an equation and asked me to be able to tell the percentage of growth or decay? In C, I should be able to look at that and know immediately it's growth, And I know that because the number in the parentheses is bigger than 1. I should be able to look at D and know immediately that it's decay, again, because that number in parentheses is smaller than 1. Now, this 1.45 as a percentage represents 145%. If I multiplied it by 100 to turn it back into a percentage, that's what I would get. This 0.9 represents 90%. So if I want to tell how much it grew or how much it decayed, I have to go back to the idea of everything starts at 100 and think about where that new number is in relation to that. So 145% is 45% bigger than 100. So that was growth of 45%. 90% is 10% smaller than 100. So that was decay of 10%. You can always subtract the original 100% out of these numbers to figure out how much it grew or decayed by if you're not sure. So like if looking at that, your brain doesn't immediately say, oh, well, that's 45% bigger than 100. Just subtract 100 from it to see how much bigger it is. That'll tell you. Or if you look at this and your brain doesn't automatically say, oh, well, that's 10 smaller than 100. Just subtract the 100 from it to see how much smaller than 100 it is. And that'll tell you that it either grew or decayed by that particular amount. Again, we're never using the exact percentage in the equation. It's always based around the idea of where it was in relation to 100. So we looked at some of those kinds of problems yesterday. We also looked at some things like this where they gave us a word problem, asked us to write a function for it, and to use that function to calculate something. So if we had a situation like this, an employee receives a 2% raise once a year. So there's my percentage, and it's a raise. If their initial salary is $60,000, what will their salary be in the 9-year period of time? So if I'm going to write a function for this, it's increasing by percentage, that's exponential growth. I'm going to start with 60,000, and I want to show that it increased by 2%. So I'm going to add 100 to that, which gives me 102%. Convert that to the decimal. Remember, dividing it by 100 to make that happen, so 1.02 to the x. That would be our function. Now, if I want to calculate where it would be at the 9-year mark, I can just plug a 9 in where the x is and calculate that. So I'll grab the calculator, 60,000, 1.02, up caret 9. And I find out that after 9 years, the person working this job is making $71,705.55. So in these word problems, we're reading closely to see if it's growing or decaying, adding or subtracting the 100 so we can do it, and then writing our function like that. We'll look at a couple more. This one says a new social media site is increasing its user base by 6% per month. If they have 21,740 users, what will their base be 8 months from now? So our starting amount, 21,740. It's increasing again, which means I'm looking at growth, adding 100. So increasing by 6% would bring us to 106%. Again, got to convert that to a decimal, 1.06. And then I've got the function that I need. To figure out where it is at 8 months, I'm going to plug an 8 in for x and calculate. So 21740 times 1.06, the up caret of 8. And this social media site should have about 34,650 followers at that point, or users or whatever. All right, let's look at 2 more. A robot vacuum cleans a dirty floor using multiple passes. During each pass, 22% of the dirt is removed. If the floor initially has 530 milliliters of dirt, how much dirt will be left after 10 passes? So this time it's removing dirt. That's going to be exponential decay. It's going down. And so as we write this, we'll start with 530. And so in the parentheses, since it's decreasing by 22%, I'm going to subtract 100 instead. So when I do that, I get negative 78. We're not worried about the fact that it's negative. We just worry about the fact that it's now 78%. Don't put a negative in these functions. So we're at 78% of what we were at initially. 78% of the dirt is left. And so as a decimal, that's 0.78. Again, if it's decay, this number should be smaller than 1. So make sure that we're getting a number in there that's smaller than 1 when something's going down. So to calculate how much would be left at 10 passes, we're going to plug a 10 in for x and do it. So 530 times 0.78 to the 10th power tells me that there's about 44, I guess we'll go one decimal place. Let's go 44.2 milliliters of dirt left. Can you measure dirt in milliliters? I guess so. Maybe it's volume. I don't know. All right, one more. A country pledges to reduce its annual CO2 emissions by 3% per year. So we're reducing by a percentage. If the emissions in 22 are 3,030 metric megatons, okay, what are the maximum allowable emissions in 2028? So if we're right now at, or in 2022, they were at 3030. And it's going to decrease by 3%. So we want to subtract the 100, brings us to 97%. So in our equation, that's 0.97, because that's it in decimal form. Again, we're dividing that by 100 to convert that if you're not sure. And then we have our x. There's our function. Now we need to figure out what it would be in 2028. Remember that the x represents time, so how much time passes from 22 to 28 would be 6 years. So I'm going to plug a 6 in for the x and calculate that. So 3030 times 0.97 to the 6th. And so 2,523.9, let's say that, megatons would be the answer to that. And that makes sense because that has gone down. We were looking for something to decrease. If it was at 3,030 and now it's at 2,500 and something, we've gone down. Okay, that's kind of a recap of what we did. That's what your practice today is going to be on. So on the practice today, you're going to be working on looking at a situation, determining what has happened in it based on an equation that's given to you, and then more than that, looking at some situations, writing your own function, and then calculating the value of it at a particular point in that situation. Use these notes. Use yesterday's notes, whatever it takes for you to be able to work through the problems. Please give it the time and the attention and the energy that it deserves to make sure that you're good at what this is. Probably looking at a little quiz on this in the near future. So just as a heads up on that. Anyway, y'all have a great day. Don't give this up a hard time. I appreciate y'all. See you tomorrow.